part 3 of our discussion of example problems with regards to function is providing a formula for a certain setting. Let's recall that basically functions are equations, right? Let's say we have y as a function of x. This is an equation wherein you have two variables, x and y. X is the independent, while y is your dependent. Okay, so in this particular problem, it says here that let us express the diameter of a cylindrical can. So we have a cylindrical can as a function of the height. So you have a can, cylindrical can, and that can has height, of course, as its basic dimension, and it has diameter, because the top and the bottom are actually circles. Okay, so we want to come up with a function of the diameter of that cylindrical can as a function of the height. So basically, we are asked to solve for a formula, to provide a formula such that if I know the height of the cylindrical can, I can solve for the diameter. Now, the parameter given to us is it has a surface area. The cylindrical can has a surface area of 16 pi square inch. It says here that 18 pi square inch of sheet metal are used in the cylindrical can. So the surface area of the cylindrical can is equal to 18 pi square inch. Now, if we examine the cylindrical can, if we examine it to simplify the concept of surface area, okay, it has actually three surfaces. Okay, I will draw the cylindrical can. So let's say that is our top, and then the body, and then the bottom part. Okay, so we have first, second, and the third part. The first and the third part are circles. Okay, and then the second part is actually a rectangle. The body is actually a rectangle which was rolled to form a circle. So the surface area is equal to a rectangle and then plus two circles. Okay, so the circle is very easy. That is pi d squared over 4, while the rectangle, basically a rectangle is length times width, but the length of the rectangle is equal to the circumference of the circle. Okay, the length here, that is actually the circumference. So area of the rectangle, so circumference is pi d, and the width here is the height. Okay, so the rectangle has the formula for the surface area of that particular part of the cylindrical can is equal to pi d, which is the length, times height. Okay, so surface area is equal to pi d h plus 2 times pi d squared over 4. So pi dh plus pi d squared over 4, or it will now be over 2. Let's continue. Our surface area is equal to 18 pi square inches. And is equal to pi dh plus 1/2 pi d squared, or pi d squared over 2. So let's simplify our equation. We can multiply 2 over pi, okay, and it will yield 36 is equal to, now pi cancels out. As a result, from all the terms, pi will cancel out. So 18 times 2 is 36, and then you have 2dh, 2 cancels out here, and also the pi plus d squared. So we have d squared plus 2dh minus 36 is equal to 0. Now this equation should remind you of the basic quadratic equation, algebraic. Let's recall our algebra. The quadratic equation is ax squared plus bx plus c is equal to 0. And to solve for x, we are given the quadratic formula, negative b plus and minus square root of b squared minus 4ac square root of b squared minus 4ac all over 2a. Now the reason why the quadratic formula is applicable to our equation is because it is in quadratic form and we are looking for d. And similarly here, we have ax squared, and x squared is also in square, similar to d squared. So what is our a? What is our a? Our a is the numerical coefficient of x squared. So here, the numerical coefficient of d squared is 1. What is our b? b is the numerical coefficient of x. So our x is d, so therefore the numerical coefficient is 2h, while c is equal to negative 36. So let's go ahead and apply those values to d. d equals negative b, so negative 2h plus or minus square root of b squared, so this will be 4h squared minus 4 times 1 times negative 36 all over 2a, so all over 2. Let's simplify further. So we have negative 2h plus and minus square root of 4h squared. Then actually let's go ahead and factor out 4. Let's factor out 4 inside the square root, and we will have h squared plus 36 all over 2. The square root of 4 is 2. So we'll have negative 2h plus and minus 2 square root of h squared plus 36 all over 2. So what happens is 2 will cancel out. We will factor out 2. We have negative h plus and minus square root of h squared plus 36 all over 2. So 2 cancels out. For the final answer, we will select the positive option instead of the negative, because if it's negative, it will be negative h minus the square root of h squared plus 36. The numerator will be negative, and we don't have a diameter that is negative because we're talking about a length. So we will select positive, and this will now be our answer. H plus square root of h squared plus 36. Okay, so we now have diameter as a function of height. If I know height, I can solve for the diameter.